Hey guys, in the next few videos I'm going to be talking about queues. They are similar to the stack data structure, but again it's just a different flavor on a way of storing data. And if you live in England, this will make a little bit more sense to you, but queue, I mean, think of it as waiting in line. I think those in England and Europe use queue instead of line, so for those people that'll make more sense. But if you live in the United States, or if you know English from the United States, the word queue might feel a little weird. But think of a queue as standing in line. The first item in your queue, or the first person, is going to be the front, right? The first person is going to be at the front of the line, and with the last person or last item is going to be at the back of the line or the back of the queue. When you're adding your data, you're going to add to the back, just as if there's a person that's going to get in line or get into the queue, they're going to go to the back. However, when you are removing your data, you're going to remove from the front, just like it would be from an amusement park. If you're waiting in line, if you're the first person in line, you're going to be the first person to get out of line. So because of this leads to the queue data structure to have a FIFO property, which means that it is first in, first out. And like with stacks, this can be implemented with a linked list or a dynamically allocated array. And of course, because I love pain, I'm going to be using a dynamically allocated array. So why don't we look at an example of adding data to a queue. So this is called enqueuing, where we're adding the number 4 to our queue. It's going to go to the front, and then we're going to add another number, let's say 9. 9 gets enqueued into our queue, and then 2. We add another 7, and this is going to be our queue, right? We can think of these numbers as items that are waiting in line, but when it is time for these items to get out of line, when we remove data, also called dequeuing, we're going to delete, or I guess remove or dequeue the first item that we added, which was 4. And then we keep dequeuing, and what this leads to is that we keep removing items at the front of our queue, or at the front of our array, or at the front of our linked list, right? And if I remove 3 items, I would just be left with just 1, which is 7 here. So this is kind of the theory that surrounds queues, and in the next video I'm going to begin the oh so fun process of writing a queue using a dynamically allocated array. And I'll see you for the next video.